Okay, number 15 guys, here we go. So we got a curve C1 shown in figure 3 has this equation, okay? So it's a standard quadratic equation. So this is C1. And it looks like we also have a C2, another equation here, with this equation, which is actually a log equation. So half x plus the natural log of 2x. And of course, they're both non-intersecting. Now, before I skip this, at C1, we also had a random point P, which is with an x coordinate of half and a y coordinate of 2. So what I did here, and before I get to this line, I assume that the point half is here. I mean, it could be here or here. It doesn't really quite make a difference because this is not scale. And to be honest, you could actually work out where it is. Because since this is a curve, you can find the turning point by differentiating and find an x coordinate. And if you did, this x coordinate would be 3/4, by the way. So half would have to be on the left side. But anyway, for the purpose of this, that's what we have. So this, let's call this point P. And it says that the normal to C1, so the normal to C1 at the point P. So here's point P. So the normal would be, I mean, this would be the tangent firstly, and the normal would be perpendicular. So it would be something like this. Well, a straight line, of course. Meet C2 at point Q. So this would be point Q. So that's so far all clear. So far so good. Now find the exact coordinates of Q. So what we could do here firstly is to work out what the normal to C1 is. So I would call this line y equals mx plus c at point P, since that's the normal to C1, right? Where m in this case is the perpendicular gradient. Makes sense because the tangent gradient is just regular dy dx. So the perpendicular gradient would be dy dx reciprocated and sign flipped. Now to work this out, we're looking over here. So we use the C1 equation, which is the quadratic, and we differentiate that using dy of dx because this is the definition of a gradient equation, and you should get 8x minus 6. So this is very simple to differentiate. Draw the power here so you get 8, remove the x here, and then constant disappears. Okay, now we say at point P, because that's the interest of the gradient, that's exactly what we want. At point P, x is a half, so plug in half into the equation and you should get minus 2 as the normal gradient, the tangent one. To get the perpendicular gradient, you just take the reciprocal of 2, so it's a half, and change the sign to positive, so m is a half. Now we have, if we put m back into the equation, we have y equals half x plus c. Straightforward. And now to find the y-intercept, i.e. the c value, just make c the subject, like I did here. Pick the coordinate p again, because we know one of the coordinates of p, which is here. You know, I should actually label this p actually. So this was p, yeah? We know the coordinates of p already, which is half and 2, so that lies on the line. If you plug it in, we can find the exact value of c, which would be 7/4. And then we can say, hence, equation of the normal of C1 is going to be half x plus 7/4. Now that bit is done. So now we can say that this line is going to intersect with this curve C2. So we can make a simultaneous equation between the new equation here, the straight line equation, with the log equation here. So I did over here actually, intersection between these two. Now because they both have y equals, like over here, y equals half x plus ln 2x, and the other one is y equals half x plus 7/4. If you just equate them because they both have y, it becomes like this. And then you can just say, okay, we can cancel the half x on both sides. And now we're left with 7/4 and ln 2x. Now this is easy, guys. Just take the exponentials on both sides, so the ln cancels out and you're left with an e to the power of 7/4, which I did over here. And lastly, dividing 2 across, you get the x coordinate of q, which is half times e to the power 7/4. Now, this one wants the answers in exact coordinates, hence the 8 marks. Now, to do that, just sub this into either equation, which is the line equation here, or the C2, because that's what point Q is on. Q is in either one of the two equations. Personally, I would use the simple equation, the line one, because it would be easy to solve. So I would use this equation, only because you have to multiply the x coordinate by a half. And let's be honest, if you times by a half, this just becomes a quarter, like I did here. So plugging in the x value into the line equation, I get y equals half times half e to the 7/4, close bracket, plus 7/4. And then just expanding this, you get quarter e to the power 7/4. And that's it. That's your x coordinate here and your y coordinate here. So guys, that was a quick, thorough explanation. You know, I try to make it quick and fast so you can actually get to the point of this. And yeah, if you enjoyed this video as well, please give me a like, and I shall see you in the next one. All right, number 16. So figure 4 shows the plan view of the design for a swimming pool. Ooh, interesting. The shape of this pool, ABCDEA, so the whole thing, consists of a rectangular section, which is the top half, joined to the semicircle section on the bottom half. Okay. So given that AE is 2x and ED is y, and that the area, i.e. both of these combined, equals 250 meters squared, show that P meters of the pool is given by this equation here. Alright, so a few things to do then, okay? I'm going to just go ahead and try and get this all in the screen. Okay, so just what I always recommend for these type of questions is that firstly, if they told you to find the perimeter, first write an expression for the perimeter of what we know and match it to this one. Secondly, if they talk about area, calculate the area and match it to the area of 250. So basically we need to form two kind of equations. Let's work with perimeters, since perimeter in other words doesn't equal anything. So we can say that perimeter here, firstly we got AE, which is 2x. We also got the height, so this is y, so this side will also be y. Now, because this is a semicircle, so half a circle, we need to know that the area of a circle is always going to be pi r squared, and that the circumference of a circle is 2 pi r. Now, because we got half a circle, so the half part would be half of 2 pi r, which is just pi r, literally, and that just covers from here to here, just the half width. Now, we're working in x's, yeah? Now, one thing to note, what is the value of the radius? Well, if we pinpoint this as the center of the circle, we can see that the radius, if we stretch it across here, or here, or here, and so forth, is going to be exactly half the length of 2x, meaning that radius is actually just x. So we can update pi r as being pi x, since the radius value is x. Okay, so that's the value right here. So now we've got everything. So we can say that the perimeter is going to be 2x plus y, which is 2x and 2y, plus pi x. And that's it. That's 3 things done. Now looking at both equations, we can see that the y has been transformed to 250 over x plus this, and pi x also transformed. So basically 2y plus pi x will need to be updated to match this one later on. So before that, let's look at the area now, yeah? We know that the area equals 250, so we can right off the bat say 250 equals something. So the area of both of these together, well, the rectangle bit is just base times height, so it'll be 2x times y, so 2xy, easy. Now, again, this was a semicircle, and we established that the area of a circle is pi r squared, so half a circle would be half of this, would be pi x squared over 2. Remember, x is the radius, yeah? And that's it. Now we just add these two together. So we can say that the area, which is 250, must equal 2xy and pi x squared over 2. Now, what happens here? Well, the final equation is in perimeters and x, so the one thing we need to get rid of is the y. So what I would recommend is make y the subject for this equation and plug it to the first equation. And that's easy. To make y the subject, subtract pi x squared 2 over cross and divide 2x. This will give us 250 minus pi x squared over 2 all over 2x. Plug this into the first equation. So let's have a look. So I'll probably need some space, don't I? Actually, I'll do it here. Plug into the... Okay, let's see if we can simplify this actually. So this becomes 250 over x. So this becomes... Yep, leave as 250 over 2x minus... So we got pi x squared over 2 over this 2. So this would be 4. So it would be pi x squared over 4x. So 2 here multiplies with that. And all of this equals y. Right. Now plug this into the first equation. And when you do that, let's see what we get. So we should get... Let me change the color of the pen. Well, have a go at this and see what you lot get, yeah? So you get 2x plus 2 times all of these. So it'd be 500 over 2x minus 2x squared over 4x. Well, you know, let's cancel 1x right now. So this disappears. Double this one, you get 2 pi x over 4. And cancel the 2's, you get pi x over 2. Easy. And then simplifying this down, so 500 divided by 2 will give us 250 over x. And yep, that's it. I think we've done it, isn't it? Okay, let's see. Oh yeah, we haven't done it yet. Oh yeah, and we also need to add plus pi x. So plus pi x. And when you do that, this becomes a positive plus pi x over 2. Okay, part B now. So explain why x is between 0 and square root of 500 over pi, which is about 12.6 by the way. So this is just understanding how x and y represents here, yeah? When we look back at the shape, we can see first here, this is all to do with lengths, perimeters, and areas, yeah? X here represents a width length and y represents some sort of height or a base length. So first things first, when it comes to lengths and distances, we should always recognize that x and these values must always be positive. So right off the bat, we could just simply say that x must be positive and y must be positive, yeah? Now, looking back at the part A equation, we somehow formulated this, right? Now, if we assume that y is bigger than 0, we can say that this equation is bigger than 0. And what that means is that we have all of this now, 250 over 2x minus pi x over 4, all greater than 0. And yeah, that's it. Now, all you have to pretty much do is simply solve for x. So literally plus this across, make x a subject, and eventually you'll come to the conclusion that x is less than root 500 over pi. Now, I could go ahead and do this now. So move this to the right and, just tighten this up. 250 over 2x is greater than pi x over 4, and blah blah blah. Eventually you get to x less than root 500 over pi. Okay, that's it. I believe that's all we need to really pick from there. So let's focus on the main part, point C, yeah? So find the minimum perimeter of the pool, giving your answers to 3 significant figures. Okay, so minimum, always spot this keyword. This literally means to differentiate, always, yeah? So in this case, dp over dx, because we're working with perimeter. Always do this, yeah? Always differentiate. Reason why is because when you differentiate, you find the turning point or the gradient, and that value pretty much maximizes your value. Well, just differentiate, yeah? Just keep it simple. So here we go. So let P equals the perimeter equation. So we had it over here. Now always write it in the standard form so you can differentiate. So in other words, get rid of the fraction over x, make it x to negative 1, and just tidy up a bit so you have clean x variables, yeah? Finding the differentiate this first time, so dp over dx, 2x becomes 2. The next term, the minus 1 goes in front because you drop the power and it's subtracted by 1, so you got negative 2. And the other one, you just take off the x, because remember, pi over 2 is a constant. Don't differentiate this or get confused by it. And yeah, now all you do is set this to 0 and find the value x, which guarantees the minimum. So that's the point. When you set this equation to 0, you're basically finding the minimum point here. That's what we're looking for, literally, the minimum point, or the minimum x coordinate, which will make this at the curve at its lowest point. That's how it usually works. So when you set this to 0, you just solve for x. So if you're not sure how to do this, what I did is plus 250 x negative 2 to the right and convert it back to its usual form, so 250 over x squared. Then I just times x squared across and divided 2 plus pi over 2 across, like I did here. Smash this in the calculator and then square root. And you should get 8.367, and of course plus minus. But because we established in part B that x is a length, and because we know that shapes lengths are always positive, we only keep the positive answer. And finally, to get the minimum perimeter, using the minimum value of x, which is over here, the minimum x value, plug this into the perimeter equation and voila. Replace x with this and you should get 59.8 centimeters to 3 significant figures. Done. And that's it.